Assalamualaikum warahmatullahi wabarakatuh. Hello guys, welcome back in my YouTube channel. Today, I want to explain about vapor pressure, other properties of liquid, review of structural difference between solid, liquid, and gases. Don't go anywhere. I hope you enjoy this video. Let's begin. Vapor pressure, defined as the pressure exerted by a vapor in thermodynamic equilibrium with its condensed phase, solid or liquid, at a given temperature in closed system. The equilibrium vapor pressure is an indication of a liquid evaporation rate. It relates to the tendency of particle to escape from the liquid or a solid. A substance with high vapor pressure at normal temperatures is often referred to as volatile. Example: air at sea level and saturated with water vapor at 20 degrees Celsius has partial pressure of about 2.3 kPa of water, 78 kPa of nitrogen, 1 kPa of oxygen, and 0.9 kPa of argon, totaling 102.2 kPa, making the basis for standard atmospheric pressure. Measurement and units. Vapor pressure is measured in the standard unit of pressure. The International System of Units, or SI, recognize pressure as a derived unit with the dimension of force per area and designates the Pascal or PA as its standard unit. 1 Pascal is 1 Newton per square meter, or N times M rank minus 2, or kilogram times M rank minus 1 times S rank minus 2. Experimental measurement of vapor pressure is a simple procedure for common pressure between 1 and 200 kPa. Most accurate results are obtained near the boiling point of substance, and large errors result for measurements smaller than 1 kPa. Procedures often consist of purifying the test substance, isolating it in a container, evacuating any foreign gas, then measuring the equilibrium in the container at different temperatures. Better accuracy is achieved when care is taken to ensure that the entire substance and its vapor are at the prescribed temperature. This is often done as with the use of an isotensoscope by submerging the containment area in a liquid bath. Properties of liquid. Characteristic 1. Liquids are almost incompressible in liquids. Molecules are pretty close to each other. The molecules does not have lot of space between them. The molecules cannot squeeze closer to one another. 2. Liquids have fixed volume but no fixed shape. They have fixed volume but they not have fixed or definite shape. If you take 100 ml of water, pour water in cup. It will take the shape of the cup. Now, pour the liquid from cup a bottle. The liquid has changed its shape, and now it has take the shape of bottle. 3. Liquid flow from higher to lower level. 4. Liquids have their boiling point of above room room temperature under normal conditions, the liquid sun heating slowly changes to vapor or gaseous phase. This process is called boiling. Example: particles are held by bonds weaker than a solid yet stronger than a gas. 2. It takes the shape of its container. 3. It can evaporate to create a gas. 4. It can be frozen to create a solid. Other properties of liquid cohesion. If you have ever used or for cooking or working on a car, you know that it's nice and slippery. That's probably why you use it. It keeps three pitch from sticking to each other or the pen, and it helps engine pistons and other moving parts slide easily. One of the reasons all are good for this application is because they have low cohesion. The liquid molecules don't interact particularly strongly with each other because the intermolecular forces are weak. Example: the water molecules interact with each other more strongly than they interact with the air or the leaf itself. The interaction of the water with the leaf is an example of adhesion, or the interaction of a liquid with something other than itself. Because of the water's high cohesion, the molecules form a special shape to maximize their interaction with each other. Two like this do droop on a leaf. Adhesion: the tendency of a compound to interact with another compound. Remember that. In contrast, cohesion is the tendency of a compound to interact with itself. Adhesion helps explain how liquids interact with their container and with other liquids. Example: interaction with high adhesion is that between water and glass. Both water and glass are held together by polar bonds. Therefore, the two materials can also form favorable polar interaction with each other, leading to high adhesion. You may have even seen this attractive adhesive force in action in lab when water in a glass graduated cylinder. Viscosity. Example: compare pentane to motor oil, which is a complex mixture of large hydrocarbon, much larger than little pentane, and some with dozens or even hundreds of carbon in a chain. If you have ever poured motor oil into an engine, you know it's pretty viscous. But liquids are nonpolar and so have relative weak intermolecular force. The difference is the size. The big and then the motor neckboards which slow the flow. It's almost like a pot of spaghetti. Review of structural difference between solid, liquid, and gases. Liquid. Liquids flow because the intermolecular force between molecules are weak enough to allow the molecules to move around relative to one another. Intermolecular force between neighboring molecules. These are not to be confused with intermolecular force such as covalent and ionic bonds. which are the forces exerted within individual molecules to keep the atoms together. The forces are attractive when a negative charge interacts with a nearby positive charge, and repulsive when the neighboring chains are the same, either both positive or both negative. In liquids, the intermolecular force can shift between molecules and allow them to move past one another and flow. I have to picture about this. Picture A and picture B. I have to picture about liquids. Picture A and picture B. Picture A shows the variety of attractive and repulsive dipole-dipole interaction. Attractive interaction are shown in A and B with orientation where the positive and is near the negative and of another molecules. Color red positive and color blue is negative. In C and D, repulsive interaction are shown with orientation that juxtapose the positive or negative ends of the dipoles on adjacent molecules. Picture B. Now you can see color green is attraction and color black is repulsion. Picture B show a sample liquid with several molecules but it attracting and repulsing with their dipole-dipole interaction. Contrast with a solid in which the intermolecular forces are so strong that allow very little movement. While molecules may vibrate in a solid, they are essentially locked into a rigid structure, described in the properties of solids module. At the other end of the spectrum are gases, in which the molecules are so far apart the intermolecular forces are effectively non-existent and the molecules are completely free to move and flow independently. At a molecular level, liquids have some properties of gas and some of solids. First, liquids share the ability to flow with gas. Both liquid and gas phase are fluid, meaning that the intermolecular force allows the molecules to move around. In both of this space, the material don't have fixed shape and instead are shaped by container holding them. Solids are not fluid but liquid share a different important property with them. Liquids and solids are both held together by strong intermolecular force and are much more dense than gas, leading to their description as condensed matter. Phase because they are both relatively incompressible, different of gas, liquid, and solid at the atomic level. You can see gas, liquid, solid. To these states of matter at the atomic level, solid, liquid, and gas. Most substances can move between the solid, liquid, and gas phase when the temperature is changed. Consider the molecules hydrogen. It takes the form of ice, a crystalline solid below 0 degrees Celsius, water, a liquid between 0 degrees and 100 degrees Celsius, and water vapor or steam, a gas above 100 degrees Celsius. This transition occurs because temperature affects the intermolecular attraction between molecules. When hydrogen is converted from a liquid to gas, for instance, the rising temperature makes the molecules' kinetic energy increase such that it eventually overcomes the intermolecular force, and the molecules are able to move freely about in the gas space. However, the intermolecular force that hold the hydrogen molecule together are unchanged. Hydrogen is still hydrogen regardless of its state of matter. Key concept about the theory is: liquids share some properties with solid but are relatively incompressible, and some with gases, such as their ability to flow and take the shape of their container. 2. A number of properties of liquid, such as cohesion and adhesion, are influenced by the intermolecular force within the liquid itself. 3. Viscosity is influenced by both the intermolecular force and molecular size of a compound. Okay, thanks for watching my video. Don't forget to share, comment, like, and subscribe in my YouTube channel. See you next time, guys. Assalamualaikum warahmatullahi wabarakatuh.